Hey guys, in this video we're going to be going over our review for our quiz. The next time we meet, you're going to have a quiz on Quizizz, and then you'll be starting a new lesson after your quiz on Quizizz. So this is your opportunity to review. Now, it is helpful to write the review down. That way, while you are taking the Quizizz, you have 5 minutes for each question. As always, you can kind of go back to your notes and look at maybe similar examples. I will be going through this video very quickly because before this video you did have a 13 or 14 minute video on the unit circle, so this one won't be that long. I did pre-write all the questions, so at any point in the video feel free to pause the video and write some of the things down because I will be going through them very quickly. Throughout this video I will be going over just a basic example of each type of problem or topic we've approached and we've seen in this past week or two. However, keep in mind that your Quizizz can have, different types of questions. And I'm really focusing here on seeing if you understand the content, maybe not just memorize how to do these types of problems. So throughout this video, stick around for the whole thing because I will be saying things like, or maybe you will see something like this on your quiz, or maybe I can ask you something in a different way. All right, we're going to get started. Here's our quiz review. The topics that we're going to cover is our 30, 60, 90, 45, 45, 90 triangle, finding those missing sides. We're going to take a look very quickly at SOHCAHTOA, evaluating angles like X, theta, A, B, and so on. Then we did a lesson on angles. This is where we had a lot of those vocabulary words. We worked on drawing angles in standard position, whether or not an angle is a quadrantal angle, finding maybe a positive or negative coterminal angles, or deciding whether two angles are coterminal. And did I really just write coterminal twice? Yes, I did. Okay, that's actually very funny. And then the next one here is reference angles. And then after that, we're going to be doing very basics on a unit circle. All right, starting with our first topic, 30, 60, 90, 45, 45, 90. We're looking to find the missing sides of this triangle here. All right, finding those missing sides. Now you can use the rules. I like the rules, so I'm gonna write them here. And you have to be able to identify your long leg. Long leg is between right angle and 30, and short leg is between 60 and the right angle. So we're looking for the short leg, and the short leg times square root of 3 is equal to the long leg. That's from one of our previous videos. Well, the long leg we have, that's 3 square root of 3. The short leg we don't have, that's our y, what we're looking for, and then there's that square root of 3. Now we're going to solve for y by dividing by square root of 3, and we're going to get here that y is equal to 3. Once you have the short leg, it's a little easier when you have the short leg to find the hypotenuse, because the hypotenuse is equal to 2 times the short leg on that 30, 60, 90 triangle. So our hypotenuse, what we're looking for is x, and our short leg was y, but now we know it's 3, so our hypotenuse is going to be 6. And then just double checking there that the hypotenuse is the longest leg. I'm not going to do a 45, 45, 90 example, but keeping in mind 45, 45, 90, the legs are equal, and the hypotenuse is a leg times square root of 2. Moving up to our next topic, which is our SOHCAHTOA, we're going to be solving for the trig function here. And we have this triangle and our Pythagorean triple on this triangle. It's a 7, 24, 25 triangle. And we have angles here, which are x and theta. These angles can be listed as any variable. It could be a capital A, capital B, it could be a C, D, X, Y, Z, it could be anything. We're going to be looking for sine of x, keeping in mind SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So once again, we're going to be doing our opposite over hypotenuse is 7 over 25. I do not want decimals. Trig functions are ratios of two numbers. However, if you can simplify it, then go ahead and divide numerator and denominator by a common factor, but you can't simplify it here, so just opposite over hypotenuse. Here we are with cosine. Adjacent is leg touching. All right, so my adjacent is 24 and my hypotenuse is 25. And then with sine and cosine, hypotenuse is in the denominator and the hypotenuse is always the biggest number. Okay, always the biggest number. So if the triangle is kind of rotated, look for the biggest number for that hypotenuse. And then now tangent, we have our opposite over adjacent, and that's going to be 7 over 24. Now we're moving on. We're looking at a new angle. This angle is theta. Theta is a Greek letter commonly used with angles. You can also see a beta, and sometimes we use an alpha for angles. All right, here we are. Sine is opposite over hypotenuse. That's 24 over 25. Cosine is adjacent over hypotenuse. That's 7 over 25. And then tangent is opposite over adjacent. and that's 24/7. And then there is our final answers for our SOHCAHTOA. Okay, here we are moving on to our next topic. If you can hear my lovely dog Duke barking, don't mind him. He barks whenever fire trucks pass and there is an ambulance or a fire truck or something passing outside. All right. We did 30, 60, 90, 45, 45, 90, SOHCAHTOA, and then now we're moving on to angles, and we're going to take a look at standard position. Keeping in mind, standard position means that the vertex is at the origin and that your initial side is starting at that positive x-axis. So we're going to take a look at this first one, number 3, and we're drawing negative 120 degrees. Keep in mind that negative angles open downwards to quadrant 4. So this would be negative 90, this would be negative 180. So when I open up downwards, now negative 120 is somewhere between these two, and then that's going to be in quadrant 3. So another way that I can kind of style this question is just ask you what quadrant negative 120 is in, and then that will test also your understanding of drawing angles in standard position. So I'm just listing that extra quadrant there, even though it's not in the directions, because that might be a question you see. Now we're going to do 288 degrees, so this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees, just adding 90. We start in standard position, we open up because it's a positive angle, and then it's a little bit past that 270, and that's going to be there in quadrant 4. So once again, I can just ask you what quadrant that's in. And then now for 125 degrees, maybe you don't need to label all of the axes here to see where that lies, but you open up and you pass 90 degrees, and here we are before 180. All right, it actually should be a little bit before the half, so maybe it's even better to draw it somewhere like here. Okay, so we'll scribble this one out. And then that's going to be in quadrant 2, drawing angles in standard position. All right, our next topic that we did, so we did standard position. Next thing we did was quadrantal angles. And then keeping in mind, quadrantal angles are any angle that the terminal side of the angle lies. My light just died? I think it did. I have a little like ring light, you know, that people use on TikTok to take selfies. And here it is. There it is. Okay. So identify if the following angles are quadrantal. Quadrantal angles are any angles that the terminal side lies on an x or y axis. So what you're asking yourself, does this terminal side lie on an x or y axis? Yes, 90 degrees lies on the y axis, so this is a quadrantal. 270 lies on a y axis, so yes, this is a quadrantal. 190 lies in a quadrant, not on an axis, so it is not a quadrantal. All right, so we did quadrantal angles. Next thing we did was coterminal angles. Keep in mind, coterminal means that two angles share the same initial and terminal side. They're just on different revolutions. So we were able to find coterminal angles by adding or subtracting 360 degrees. Okay, so here I am with 210 degrees. I'm starting with that angle, and I want to find a positive one, so I'm going to add 360 degrees. You can definitely use a calculator on your assessment, and you're going to get 570 degrees here. And then you go back to your angle, and now you're going to want to subtract 360 degrees. So I'm going to do this the other way. Okay, I'm going to go like this. And then now all I have to do is make it negative. Okay, but if you're not good with maybe those basic numerical skills, that's okay. Take 210, subtract 360 in your calculator, and you're at negative 150 degrees. And then there's one positive angle that's coterminal and one negative. So I can ask you, I can give you on like a quizzy, I could say 210 or 210 and negative 150 degrees coterminal. And then you just take 210, you subtract 360, or you add it and you see if you get this angle. If you pass this angle and you don't get this angle, they're not coterminal. Now we're going to take 30 degrees and we're going to add 360. And when we add 360, we get 390. That's a coterminal angle. And then now we're going to subtract 360 from 30, and we're going to get 330, and that is going to be a coterminal angle. So we can say that 390 and negative 330 are coterminal with 30 degrees. All right, so we finished coterminal, and then I made a mistake here. I wrote coterminal twice. We're almost done. We just got reference angles and then unit circle basics. All right, a reference angle is a positive acute angle that's formed. Oh my God, my ring light. It is a positive acute angle that is formed with the x-axis. So when you get your final answer, it should be an angle that's less than 90 degrees, and it should be positive. I'm sorry, my ring light, my little power bank died, but I think that this is clear enough for us to see for my last two questions. All right, so what we do is you can draw this angle and stay in position, and you're going to see that 310 is past 270, and then you have to ask yourself, how far away is it to the nearest x-axis? What is that distance? And that distance always is going to be positive, and our reference angle here is going to be 50 degrees. That's a distance to the nearest x-axis. Now, even though it's only 40 degrees away from the y-axis, by definition, reference angles are formed with the x-axis. So once again, you're always asking, what is the distance to the nearest x-axis? And then our last question for the day here for our review is going to be on our unit circle basics. And I could just ask you a question like, what is the coordinate point at maybe 150 degrees? And I'm going to pull up our unit circle for us, and then you just really quickly, you look at your unit circle from your past lesson, and you're going to see here that the coordinate point there is negative square root of 3 over 2, 1/2. I could ask you, what is the y value at 150 degrees? You give me 1/2. I could ask you, what is the x value 150 degrees? And you give me negative square root of 3 over 2. All right, that was just a quick review for our unit circle, SOHCAHTOA, 360, 90, and everything we know about angles. Make sure you study for your quiz. I'm going to upload a quiz review as well to kind of help. All right, make sure you get to your quiz review homework and then study. Email me if you have any questions.